Hello everyone. So in this particular video, I want to talk about what should be your roadmap for PyTorch. So basically, let's say you are, or let's say you can also say deep learning. So let's say you are done with almost all of the things, let's say coding and machine learning, and you want to start with deep learning. So how you are going to start? Okay. So the first thing that you would want to cover is simple basic operations in PyTorch. So you want to cover something like torch.random, which can help you, generate some fake data all the time. So you don't have to get a data set just in order to test some functions. So let's say generate fake data, or also to see how some other functions work. Okay, so this can also be used. Then some basic as I said, tensor operations like torch.sum, torch.mean. So this is going to give you basic understanding into the working of different functions again. Okay, so these are also things, and sometimes you actually need to calculate the sum and mean. Let's say you are doing some activation function, or sorry, let's say loss function. Okay, so there you need to know all of this. Then again, torch.arange, then it is used to basically create numbers from, let's say, starting till ending, and all the numbers from here. So let's say 0 1 2, if starting equal to 0 and ending equal to, let's say, 5, so 0 1 2 3 4, something like this. Okay, so there are 5 numbers here, and there are so many other operations that I haven't even mentioned. So there can be, like, I personally would say I know 50 25 to 30 operations just on top of my head. Okay, so you should be at least familiar with 25 to 30 operations. Again, all of this comes from practice. Okay, after that, once you are done with basic operations, you should understand the concept of autograd. Okay, so we haven't started with our algorithms, but this is basically how backpropagation works. Okay, so in any deep learning model that you will use, you will need backpropagation. Why? Because in order to train the model, you need some algorithm, and for that you need backpropagation. And how does PyTorch implement backpropagation? Is through the autograd engine. Okay, so basically computational graphs are made, and then I have already made a video on the channel. You can go and see how autograd works. Okay, and then you also need to know how data loaders work. So let's say you're having a data set. Okay, and then you data set, and you want to train a model. So for that you need to know the logic of data loaders. So how to load data, basically load data, that is data loader. Okay, once you are done with all of this, then you can start with a simple neural network. Okay, and in that you can use a MNIST data set. You can also go for iris data set. You can also go for other data sets, smaller data sets, because I don't want you to go for very big data set, because training will become a problem. Okay, so there are already videos on this. Okay, so you can go and see the channel, the playlist, PyTorch playlist. There I have explained simple neural network with an example, not MNIST. Basically I think it was breast cancer data set, but whatever, you can still use this. Okay, after that, transforms and CNN. So once you are going for, after you have completed your simple neural network, you need to do CNN, but CNN will involve certain transforms. Okay, so there is already a video on transforms, so you can go and do transforms. After that you can do CNN and the same MNIST handwritten data set. Okay, MNIST handwritten data set that you can use over here. Okay, so that was the fourth one. Once you're done with that, you have to go for transfer learning using ResNet, because sometimes you want to do, let's say, classification and other things that you want to do. You will not be able to get very good results with simple CNN. Okay, let's say you want to do it on a real world data set, you would definitely want to check out ResNet. Okay, or they are different. There are other what to say, deep learning models, pre-trained models as well. For example, there is VGG, then there is AlexNet. So there are so many of them, but I would suggest strongly for going for ResNet, because this is the best according to my opinion in this field. After that, you want to go for RNNs. So basically you can there's a simple API in RNN. So rnn.rnn, and then you specify certain parameters. On that you can go for Shakespeare dataset. Now one thing that I have kept in mind is that I don't give you any dataset that becomes a problem. I want to make sure that whatever dataset I'm giving, it is satisfying two problems. That is, it is small so that you can train it easily, and second, it gives results. So it's not that you will not be thinking, oh, if my model is not working, probably the data set is bad, or my data set is bad. That is not going to be the case. Your data sets are all standard data sets. You can definitely use these. If you're not getting results, it may mean that the data set is okay, there is some implementation problems. Okay, after that you can go for LSTM, and in that also Shakespeare data set will, this is a very small data set, it's basically all the work of Shakespeare written in one text file. Okay, so this is good enough. After that you would want to go for transformers. Now till the time you come here, you're already a pro. Okay, or at least you're almost a pro, because from here you will need big data sets. Okay, you'll need big data sets and big machines to train. Okay, you might be able to do some toy data set, but again it won't give you any fruitful result. You need big stuff for that. And once you're done with that, you should finally go on implementing your own architectures. You can implement UNet, you can implement ResNet, you can implement your own architecture that you want, whatever comes to your mind. Okay, so that is when you have got the experience of all of the first 8. So according to me, this will be a perfect roadmap, and just let me know if you have any questions or doubts or any of your opinions. Thank you very much, and we'll see you in the next video. Thank you very much, and bye.